Okay. Thank you, Dr. Mirza.
So, good morning, everyone.
Ma'am, we will wait for 1 or 2 minutes and then we will start.
Okay, okay.
Yes, ma'am.
Very good morning to all of you. Hello and welcome, warm welcome to everyone present here. I, Dr. Mirza Beg, Assistant Professor of Agronomy, Vasantrao Naik Marathwada Krishi Vidyapit Parbhani. On behalf of Vasantrao Naik Marathwada Krishi Vidyapit Parbhani, Center of Excellence for Digital Farming Solution for Enhancing Productivity by Robot, Drones and AGVs. Indian Society of Agronomy, Parbhani Chapter, Indian Society of Genetics and Plant Breeding, Parbhani Chapter, and Organizing Committee welcomes you all at fourth day of morning session of International Seminar on Digital Technologies for Smart Agriculture, a futuristic plan. We are lucky to have amidst us an eminent weed agronomist and professor, Dr. Rima Labad from Farhat Abbas University, Algeria. Now may I request Dr. Sunita Pawar Madam to kindly introduce the speaker to the participant. Ma'am.
A very good morning to all of you. Thank you, Dr. Mirza, for giving me this pleasure. It's my pleasure to introduce our today's speaker, Dr. Raima Lab, who is working at Department of Agronomy, Farhat Abbas University, Algeria. She is having 6 years of experience in teaching and research. She has completed her research on environmental aspects of conservation agriculture. She is having a very bright academic career. She has participated in many national and international events also. She is having several publications in national and international journals. She is having her future research projects on digital technology for herbicide and selective pesticide application, herbicide robotic applicator mechanism, UAV design and development related to herbicide application, AGV hardware and applicator software for herbicides, digital technologies for organic agriculture. She is having her MOU in progress with Farhat Abbas University, Algeria. Today, she will interact with us on the topic Advanced Automated Herbicide Applicator Mechanism in Algeria. Welcome, Dr. Raima ma'am. You may now please share your screen and you may now start your presentation. Raima ma'am, please.
Thank you, madam. Good morning, everyone. Good morning, everyone. I'm Dr. Rima Labad from Farhat Abbas University, Algeria. I'm an engineer in agricultural mechanization and I got my doctorate in soil, water, and agro equipment. My scientific works are based on cereals, herbicides, and irrigation according to agricultural systems,
Volume.
soil characteristics, for sustainable development. Before talking about agriculture in Algeria, I have to give you some information about what are the types of culture cultivated in Algeria, what are the agricultural systems practiced, and what is the situation of smart agriculture in Algeria. Before talking
Sorry to disturb you, ma'am. Ma'am, Rima, ma'am.
yes,
Ma'am, your voice is very much low, and participants are asking to increase some volume.
okay, I will try.
Just try once. Otherwise, you remove your headphones and you speak like this only by your system voice.
Rima, you can use your microphone on laptop. You can use your microphone, remove your headphone, and just talk like the speaking in general way. Yeah, yeah. Make a loud voice, and then you can start.
Okay. You can hear,
Shall we?
ma'am?
Yeah.
Yeah,
Yes.
You can hear?
Yes.
yeah.
Yes, ma'am.
But little bit loudly. Little bit loudly. Yes.
So I will repeat. So before talking about smart farming in Algeria, I have to give you some idea about what are the types of culture cultivated in Algeria, what are the agricultural system practices, and what is the situation of smart agriculture. You have to know that we have 70% of agricultural area used. The most important area is considered about cereal and the other culture as potato, olive tree and fruit trees and other culture such as palm date. And we have in another way no cultivated area. So we observe that cereal are the most important culture cultivated in our country. That's why my research works are based on cereal. To improve cereal productivity in our country, we introduced conservation agriculture since 2005 to increase cereal production. Conservation agriculture is based on simplified techniques using cover crops and special seeder, or using direct seeding with special seeder. The first problems with our farmers to adopt conservation agriculture is about disponibility of special seeder. That's why our engineer developed this Algerian seeder to adopt in our soil characteristic and our climate. Have to know also that direct seeding need the use of herbicides. So after 10 years to adopt conservation agriculture, they remarks some inconvenient. The target or the aims below is to reduce soil erosion, increase soil quality, and preserve soil water. But the most important inconvenience are how to manage water, because the zone of cereal production in Algeria is located in arid and semi-arid area when rainfall is varied between 500 and 200 millimeter, and we know that cereal need an average of 500 millimeter. So in this located area, cereal are suffered from water deficit. So the first inconvenient of conservation agriculture, it's how to adopt our cereals or how to increase our production in this semi-arid and arid area. The second inconvenient is about the use of herbicides. Throughout our research work, we mentioned that the use of herbicides can affect soil quality and the grain quality. This research are published in collaboration with Dr. Gopal in Journal of Agronomy and Indian Journal for Agricultural Research, and we show that there is soil pollution caused by herbicides using in direct seeding, and this contamination or this pollution are transferred for the grain. So these two problems, to solve these two problems of water efficiency and soil pollution, we are thinking now to introduce smart agriculture in Algeria. You have to know that in 2019, smart agriculture was piloted in Algeria to help local farmers to reduce irrigation costs and monitor inputs that affect crops, including the use of herbicides. So, the smart agriculture is a new techniques adopting in Algeria. In 1 year or in the first year, we make some research divided by survey with farmers and some experiment on the field. And the first operation was done on December 2019. It's a survey with some farmers. We ask some questions for farmers to the ability to adopt smart agriculture and their farms. Remarks that 60% of agriculture of farmers agree with adoption of smart agriculture, while 30% disagree with adoption of smart agriculture, and 10% they have no idea about smart agriculture because it's a new technology in our country. So 30%, the most important remarks here, it's about 30%. 30% of farmers think that smart farming needs high cost because they use a tractor, a high presence of tractors and specific systems. So they think that smart agriculture maybe needs high cost. Also, 30% of farmers have a small farms area, so they think that smart agriculture is adopted to the high farms area. Also, until now, because it's a new technique and a new system, there are no results are proved until now about smart agriculture. But in the other ways, we make it some research or some experiment in the field. The first experiment, it's about weeds treatment. We use in this experiment, we are using drone to take some maps. After that, using the remote sensing, we are located or we are delimited with the area of width development. After that, after delimited surface of width development in the field, we are associated a GPS on sprayer to determine area treated to avoid repetition of area treated and use the quantity of herbicides necessary for weeds distribution on the field. The first observation in the field show that the quantity of herbicides used using GPS it's less more it's less than the use of sprayer without GPS. So using GPS, we are controlling the quantity of herbicides put in the soil or putting in the weeds. The second experiment is about water management according to local wheat varieties. We have we have 19 variety of wheat, and each variety have specific characteristics. That's why we are starting to determine crops coefficient of our variety using Lisimetric system. This value of crops coefficient was interpreted using remote sensing with ERISAT software to have or to give exact crops coefficient. We know that crops coefficient needs to estimate crop water requirement. Our results in the first year, from December 2019 to June 2020, where the results found that the crops coefficient obtained are different from the value given by the FAO. So this value help us to estimate crop water requirement, consequently reduce water quantity for irrigation. So this result is about 1 year. They have another experiment. We will do it in the next year to confirm our results. In the other ways, to manage also to manage water in the soil, we use some tensiometer and some electronic meteorological station. So to evaluate soil moisture and the depth until 60 centimeter, the depth of development of roots of cereal, we can have an idea about soil moisture and the depth according to rainfall, because meteorological station according to some software give us the rainfall in the specific region, so we can estimate the quantity of water using for crops development or for cereal development. This method using this tensiometer and this meteorological station are giving the appreciate results about soil moisture and roots development and soil depth. So using the Lisimetric system and using the tensiometer can increase or can make us decision about irrigation dose according to hydraulic soil characteristic, so we can improve our yield for cereal. what we have, I have to say that in this first year of adoption of smart agriculture, some farmers estimate that smart agriculture may be a solution for our agriculture and solution to increase our yield. But the problems is about cost, because we have no idea about economic effect of smart agriculture. The results found during the first year for adaptation of smart agriculture in Algeria are very encouraging. The result will be diffused for farmers to adopt these techniques, but it's necessary to collaborate with other laboratories to develop our field research according to our conditions, to our soil, to our climate, to water resource and culture, because you have to know that in Algeria, in, in the zone of cereal production, the water it's limited factors. Even the wheat development, it's a big problem that the big problem that maybe affect yield production and cereal yields. So smart agriculture from since 2019, we think that smart agriculture maybe solve our production and maybe uh, increase the the quality of our product. And finally, I have to say thanks for Dr. Gopal and for all member of seminar, and thank you for your attention.
Thank you very much, ma'am. It was quite interesting to listen your lecture. Can you put some little bit highlight on regarding how your automation of using the herbicide means you are using the GPS technology to apply the herbicide, right? So how
Yes.
you are using actually the practical utility of that system?
In the normal conditions, we use sprayer without GPS. As traditional method, we have to put water and herbicides, active matter, and put it in the spray and use some nozzle, specific nozzle for cereal, and treat our weeds. But in the first, in this years, it's the first years we use GPS to control the surface treated, because to avoid the repetition of treatment, or the repetition to put twice or three times the herbicides on the weeds. So compared this method using GPS and without GPS, we remark that the volume or the quantity of herbicides using, it's less without GPS. So with GPS, we can control the quantity of herbicides put it in the field.
Thank, thank you, ma'am. One more question related to that aspect only. Which method means, I mean to say whether you use it by sprayers by tractor method or drones method has been used, adjusted with the GPS while spraying this herbicide in the field.
Sorry, I didn't hear your
Uh,
question.
uh, Ma'am, means when we are using this GPS technology, which kind of sprayers were used? Means I mean to say whether it was the tractor mounted GPS with the sprayers or it was the drones that has been used for spraying this herbicide.
No, it put it directly in the sprayer.
Okay.
We put sprayer in the tractors, and we
Mhm.
put the GPS on sprayer.
Okay.
Yes, we using the drone before put it the GPS. We use the drone to take some maps
Mhm.
and to determine surface of width or repartition of width. After that, we put it GPS on the spray.
Okay. Got it. Got it. And one more thing, ma'am, your lysimeter experiment regarding the calculation of crop coefficient. for
Yes.
water requirement of crop. Can you a little bit give in detail about explanation, means a little practicality? Means
Uh,
lysimeter was used for determination the crop coefficient, and the crop coefficient that you found was totally different from what the crop coefficient given by FAO.
yes, we
Huh.
use Lisimetric methods.
Mhm.
Uh,
We use Lisimetric method. In the Lisimetric method, we have to calculate inputs and outputs, water, rainfall, irrigation,
Mhm.
and we have to calculate
may I have Rima,
yes,
are you able to hear me?
yes, I can
Yes.
hear you. Yes,
Like to see some of the videos we have prepared before this. If you have, I think again disconnected. Are you able to hear me?
yes, I can hear you. Yes,
Yeah. Do you have videos, if any, you want to show about the digital practices or any exposure to this forum? Because I like to introduce our Professor Dr. Sunita Pawar, Professor Mirza. They are working for herbicide applications, and they will be associating with you because you are during research time. We have done so many manual methodic tools, and then after that also digital softwares that we are used. So now it's time to make the IoT tool. IoT tool reaching this technology to the farmer's hand. As a Satif University Vice Chancellor, your rector, and your associated team have agreed to work because Arabic crop culture and herbicide is quite correlative, and our professor scientific group from VNMKV, they are interested to have a collaboration with you. So I like to invite you in this regard to proceed for the robotic and agricultural drones development in this forum. Uh, Raima, do you have some video?
I will now. I will check in my laptop.
Okay, okay. Still then, we will have some chat box questions.
I
Chat
will
box.
I
Professor
will
Mirza and
send
Pawar
it for you.
will continue.
Yeah.
When I found the video, I will send it for you, Gopal.
Yeah, but right now, can it be shared through the screen? Can you share with the screen?
Yes, I will.
Ma'am,
One question.
one question is there from Shubham Sinha. He has raised the hand. He want to ask some question. Mr. Shubham Sinha, kindly proceed and ask the question. Shubham Sinha.
Okay,
Mr.
ma'am.
Mr. Prakash Singh. Mr. Prakash Singh.
Okay, ma'am. Am I audible, ma'am? Raima, ma'am? Yes, ma'am. I want to ask one question. Whether there are some comparative studies regarding the quantity of herbicide required in the manual application and the automated, that is GPS-based application of herbicide. If there are such studies in your research?
Sorry, madam.
Yeah, actually, this is what we thought of. The herbicide applicator calibration for the robot uh, articulated arm. We are making this kind of mechanism with some degree of freedom, and I suppose the team from VNMKV and the research that in goes in Algeria, we will have some comparative evaluation, and maybe Algerian university will come for this mechanism to develop for the both countries, and VNVMKV will be supplying this kind of mechanism or the machine. In fact, we are also thought of drones, and the drones with this such kind of a herbicide applicator. It can be just a think tank which can be developed in artificial intelligence. Our IIT Bombay team is ready to work for this kind of artificial intelligence. And okay, so we will be proceeding for the another set of activities, and these activities will go on for another 2 years, and then after that it will establish some collaborative exchange, which is forever. So, Raymond, do you understand my what I mean to say?
Yes, yes, sure.
Yeah,
Yes, because you know, Gopal, that the use of drone, it's a new, it's new in Algeria. It's the first this year. It's the first year we are using drone.
yeah.
So we didn't use drone before.
Is there any restriction in Algeria to run and apply this drone in agriculture?
We are using drone in collaboration with the specific institute. This institute is depends on military.
Yeah, that's military organization will restrict
Yes,
the range and the limits of
yes.
the drones to fly,
They
because
give us
uh, it
permission to use drone.
may yeah.
Yes,
Uh,
because
how do
before
you experience Algerian and the European machinery development differences for
yes,
herbicide?
yes. Before the use of drone, we use only samples prior, the sample techniques as using in intensive farming or conservation agriculture.
Okay, ma'am. One another question is there. If there are some problems on herbicide drift in case of using these herbicides with the help of drones,
Your voice,
problems of drift.
madam, please.
Yes, ma'am. Am I audible, ma'am?
Yes,
Hello?
yes,
Raima, ma'am. If there are some problems of herbicide drift on sensitive crops while using these herbicides with the help of drones,
yes.
herbicide drifts.
Rift, yes, they exist in recent my recent paper. I works on drift or residue of herbicides in cereal seeds. They exist in with high level. So after harvesting, we found that cereal seeds contained a high level of herbicides. So this herbicides transfer from the soil to the fruits.
Thank you.
One thing, ma'am, we need to even continue with the research of using these digital technologies and manual technologies. A comparative study need to be done, because where the herbicides used are much higher, certainly use of digital technologies will reduce it. It will become a more precise, because in case of manual application, more than one or twice herbicides playing application might be done. But in case of GPS technology, by using that one, we can minimize the use of herbicide, and that by that way also we can reduce the residue accumulation in fruits and cereal seeds also.
Site
Yes,
specific we can use.
is
Site specific
it
application of
is
herbicide.
our objectives the use of smart agriculture or precision agriculture. It's our objective to reduce the dose of herbicides using and to reduce soil pollution. This is objective of the use of smart agriculture.
Yeah, that's true, that's true. And beside it, we need to even work over the cost of application by using the smart technology and the traditional one, because unless and until we do the comparative study about the economics, we may not able to convince the farmers also. That is also a part.
Yes, yes, especially when we are working with the small farmers. It
Hmm?
means farmers that have small farms, small area. They hesitate to introduce smart farming because it say that maybe it will be very cost. So we need special or not special, but techniques that increase the cost of herbicides and give more results about sustainable development.
Yeah, we in agronomy department, we have conducted one experiment regarding the comparative efficacy of application by manual application of herbicide and by using the drones also. And we have found quite encouraging result about that also. Beside it, using drones while during even the soil has got more moisture, or there is a problem of going into the field which are unaccessible, that problem can also be solved by using the drones for spraying the herbicide.
Yes, sure. Yes, I'm interested in herbicides because it's my domain. That's why I'm based on herbicides and it's used on cereal.
Yes.
So
Along,
yes,
yes. Along with this, the
Raima,
efficiency.
can you talk about organic farming? How is it practicing in Algeria? Because we are launching so many practices now. The organic farming are to be digitized. So digitized means digital technology application intervention for the organic to identify and isolate how is it different than the chemical pest to know how if the herbal the kind of organic farming applicant and non-farming organic farming applicants how we can identify use of by use of the digital tools and equipments. So, Raima, can you tell about the organic farming in Algeria?
yes, there exist organic farmer in Algeria. When we use the we are using traditional tools as plow, as cover crops, and using some organic matter to produce cereal and using natural organic matter to improve or to increase soil fertility, but not using digital tools. We are you are using the traditional tools as plow, as cover crops and cultivator or rotavator. But the input, the organic input, we are using natural organic matter. Hello?
Hello.
Thank you very much, ma'am.
Hello?
Thank you very much. Hello, am I audible, ma'am?
Hello?
Raima ma'am.
Hello.
Hello.
Yes, yes. Hello? Yes, I can hear you.
Thank you very. Thank you very much, ma'am. That session was very informative regarding the use of digital technology. Hello. Hello. Am I audible, ma'am?
Yes, I hear you.
Ah, thank you, Rima, ma'am. Thank you. It was a very
Yes,
informative
continue.
session.
Yes,
Yeah,
Mirza.
it was very informative session, ma'am, regarding the use of digital technologies for use of herbicide, particularly the use of GPS. It was quite impressive because comparatively, when we are talking about the reducing the use of agrochemicals, this technology will definitely help in reducing the use of repeated use of herbicide. A specific or pinpoint application where there is a weeds are there, we can apply the herbicide and reduce the use of that herbicide. I'm sure that this discussion and your presentation has helped the participant to understand about the use of this herbicide, particularly the digital technologies and GPS in using the herbicides. And beside it, there was another discussion regarding the calculation of crop coefficient. That was a new technique. Means it was really when FAO has given some other output and crop coefficient, and your experiment has suggested some more. It means that digital technologies can improve this crop coefficient and reduce the use of water. Thank you very much, ma'am, for your valuable information and discussion. Once again, on behalf of VNMKV, NAHEP, Indian Society of Agronomy Parbhani chapter, Indian Society of Genetics and Plant Breeding Parbhani chapter, and all organizing team. Thank you very much. Thank you very much.
Thank
Have a
you.
nice day. Have a nice day,
Thank
ma'am.
you. Have a nice day.